Have you ever wondered why everything in the universe is spinning and yet we feel completely still? But you are not still at all. Right now, the ground beneath you is spinning. The planet is falling through space. The solar system is sweeping through the galaxy at a speed so vast that no word in any language sits comfortably beside it. And somehow, you feel none of it. Tonight, we are going to follow that mystery. Slowly, gently, without hurry. So let yourself settle now. Let the weight of your body sink into wherever you are lying. Let your jaw go. Let your shoulders drop. You don't have to hold anything together tonight. There's something I want to begin with. Something familiar, actually. You've been on a long flight, maybe. Or a night train. You're sitting there, somewhere far above the earth or racing through the dark. And someone sets a cup of tea on the tray in front of you. The tea sits perfectly still in its cup. Completely still. As if nothing is happening at all. But you're moving at hundreds of miles an hour. The tea doesn't know that. Your body doesn't know that, not really. Because you and the cup and the plane are all moving together in the same direction, at the same speed. There is no difference between you and the motion. So the motion disappears. Follow that idea a little further. That is the earth. And you are the cup of tea. The earth spins at the equator, fast enough that if you could step off it for just a moment and hover in place, the ground would rush past you faster than the top speed of a commercial jet. On top of that, the whole planet circles the sun at a speed that would carry you from one end of a country to the other, in under a minute. And on top of that, right now, tonight, while you lie here, the entire solar system is sailing around the center of the Milky Way at a speed so large, I almost don't want to say it out loud because it sounds made up. And the tea sits perfectly still in its cup. Your body has no instrument for steady motion. The part of your ear that senses movement, that tiny structure of fluid and hair, evolved to detect a stumble on uneven ground, a child reaching out to catch themselves. It was never designed for the rotation of a planet. It can only feel a change, a start, a stop, a jolt. Steady, smooth, ancient motion. The kind that has been happening since before the first human ever looked up and wondered. That kind is invisible to us. And here is something researchers are still working out. Your sense of motion isn't fixed. The threshold shifts, depending on what you're attending to, what you expect to feel, even how rested you are. There is no clean line between felt and unfelt motion. Only a gradient, constantly adjusting. Which raises a question worth sitting with. If the boundary is that fluid, how much of what we call stillness is physics? And how much of it is simply attention, turned the other way? I remember the first time I really understood this. I was standing in front of one of those long pendulums, the kind you find in old science museums, hanging from a very high ceiling swinging back and forth with this slow, hypnotic patience. Around the base, there were small wooden pins arranged in a circle, and over the hours, the pendulum would knock them down one by one, as its arc gradually rotated around the circle. But the pendulum wasn't rotating. The floor was. I stood there for longer than I should have, just watching, feeling for the first time what it actually meant that the earth was turning, not as an idea, not as something written in a book, but as a real, physical, quiet, ongoing fact. The pendulum was measuring the planet. That is not a metaphor, that is what it was doing. And there is a strange comfort in it. That something so enormous can be so gentle, that you can be carried at impossible speeds and feel only stillness. The Earth's spin has been with us since the very beginning. Long before there were oceans, long before there was life, there was a cloud of gas and dust drifting through space, and somewhere inside it, the faintest, most delicate rotation had already begun. When that cloud collapsed under its own gravity, something happened. The same thing that happens when a figure skater pulls both arms in tight. Spinning faster, not from added energy, but because the same spin now has less space to fill, and so it tightens, accelerates, pulls inward. That is how a planet is born spinning. The Earth's rotation is a fossil, the memory of that first gentle turning, pressed into the motion of a world 4.5 billion years ago. That spin has been slowing down ever since. Very, very slowly, the way a river gradually widens as it nears the sea. The moon is doing it. Its gravity reaches into our oceans and tugs at them, raising the tides, and that tidal friction, that gentle resistance, costs the Earth just a whisper of its spin with every passing year. If you were alive in the age of the great dinosaurs, your day would have been about an hour shorter. Go back further to the earliest chapters of our planet, and a full day lasted only a few hours. The world was spinning so fast then that the stars would have wheeled overhead not in hours, but in minutes. Scientists look for that ancient rhythm in layered rock, tidal deposits laid down in Precambrian seas, each thin band a day, each cluster a lunar month, millions of years compressed into stone you could hold in your hand. And yet the exact spin rate of the very young Earth in its first billion years remains genuinely uncertain. The early solar system was chaotic in ways the models still struggle to hold. There are competing theories, and the data points don't all agree. What do you think the young Earth looked like, spinning that fast, with no moon yet pulling at it? Oceans of magma instead of water. All of that energy hasn't vanished. It moved from the Earth to the moon like a quiet gift passed between two things that have been dancing together for longer than memory. The moon drifts a little further from us each year because of it, slowly, by about the length of your hand, inching away into the dark. Ah, cosmic slow waltz. One partner gradually letting go. Stay with that. Just breathe. Let your chest rise and fall Notice how the mattress is already doing the work of holding you. Feel the coolness of the air against your skin. You are lying on a spinning world, and the spinning world is making no sound about it at all. Everything you feel right now, the stillness, the quiet, the sense that nothing is moving, is real. And at the same time, it is the most complete illusion in physics. The stillness you feel is not the absence of motion. It is motion so deep, so old, so perfectly shared between you and everything around you, that your body simply has no word for it. No sensation to name, no feeling to report. Only this quiet, this weight, this breath. And somewhere at the edge of sleep, a question is still turning. If the earth learned to spin from the cloud that made it, and the cloud learned to spin from what came before, then somewhere, at the very beginning of everything, there was a first rotation. The very first spin in the history of the universe. The physics allows for it. The mathematics can describe it. But why the universe began with any rotation at all, rather than perfect, absolute stillness, remains one of those questions that sits quietly at the base of everything, and has no clean answer yet. Let it sit there. You don't have to solve it tonight. Neither does anyone else. Let me ask you something. When you think about the moment the universe began, what do you picture? Perhaps a great explosion. Light blooming from nothing. A clear, clean beginning before it. Nothing at all. And after it, everything. But what if the very first thing that happened, before atoms, before light, before anything with a name, was a turn? Not an explosion, not a flash, a twist. We tend to think of the Big Bang as a beginning of things, of matter and energy erupting outward. But there's something the simple picture doesn't tell you. It wasn't just matter that appeared. It was motion. And not random motion. Not particles flying in all directions with no preference. No pattern, no lean. Something in the very earliest universe, in a sliver of time so small that every word we have for brief is laughably too large. Something tilted. Something preferred one direction over another. And that tiny preference, that infinitesimal asymmetry, may be the reason you exist tonight. Lying here, breathing, spinning silently through the dark. There's an idea I keep coming back to, one that I can't quite put down. Imagine a universe where everything is perfectly balanced, perfectly symmetrical, every particle matched by its mirror, every force perfectly cancelled by an equal opposite force. In that universe, nothing moves. Not because there's no energy, but because every push is met with an equal pull. Every lean to the left is answered by an identical lean to the right. Perfect balance is, in a strange way, the same as perfect stillness. For something to move, for anything to move, the balance has to break. And in the first fractions of the first second, it did. The forces that shape our universe, gravity, electromagnetism, the forces that hold atoms together and pull them apart, were once, impossibly, a single thing. One unified force, one perfect symmetry. And then the universe cooled, the way a breath of steam cools into water, the way water cools into ice. And as it cooled, that single force began to separate. Gravity peeled away first, then the others, one by one, like the layers of something coming undone. And in the peeling, in the breaking, tiny imperfections appeared. Tiny imbalances, tiny preferences. A universe that had been a perfect mirror became, in the most subtle and delicate way, slightly lopsided. And a lopsided universe can spin. There is something in the oldest light in the universe, a faint glow that has been traveling since the universe was only a few 100,000 years old, that carries the memory of all this. That ancient light is everywhere, right now, passing through the walls of the room you're in, passing through you. And when instruments were built sensitive enough to listen to it, instruments that can feel temperature differences of a millionth of a degree, some researchers thought they found something unexpected inside that light. Something that looked like a pattern. Not a random scatter. A possible pattern. A faint alignment. As if the light was not quite evenly distributed across the sky, but had a very slight, very ancient lean. A preferred axis. Some called it, with a little dark humor, the axis of evil, because it was the kind of signal that wasn't supposed to be there, and because it made people uncomfortable, including the people who found it. A universe born without preference shouldn't have a favorite direction, but the light suggests it might. No one is certain what it means. I want to be careful here, because this is the kind of thing that is easy to make sound more certain than it is. This is still a question, not a conclusion. It might be a flaw in the measurements. It might be something about the way our instruments see the sky. Or it might be the oldest fingerprint in existence, the trace of a spin that was already present, before stars, before atoms, before the concept of before had any meaning at all. What we do know is this: the universe was not born uniform. There were ripples, tiny variations, some places slightly denser than others, some places slightly warmer. And those variations, those whisper-thin differences, are the reason everything exists. In a perfectly uniform universe, gravity pulls equally in all directions. Nothing clumps. Nothing gathers. There are no stars, no galaxies, no planets. Just an endlessly thin, endlessly even fog of particles, spreading forever apart, into a darkness that never becomes anything. But because there were ripples, because the balance was slightly broken, gravity had something to work with. The slightly denser places pulled more. The slightly denser places grew denser still. And as the clouds collapsed, they spun, For the same reason that skater spins faster when she brings her arms in, and the spin became galaxies, and the galaxies became stars, and the stars became everything. Every galaxy you have ever seen in a photograph, that slow, breathtaking spiral, is the direct descendant of one of those ancient ripples. The spiral is not decoration. It is ancestry. When enough galaxies were catalogued, hundreds of thousands of them, some researchers reported a pattern that wasn't supposed to be there. A few careful studies have looked at hundreds of thousands of galaxies across the sky, some near, some so distant their light set out before our sun was born, and found what looks like a very faint, very subtle imbalance in the direction they rotate. More seem to lean one way than the other. I should say honestly, this is contested. Not every analysis finds the same signal. Some researchers think it's real. Others think it may be a statistical artifact. The debate is ongoing and unsettled. But if it is real, just barely, just statistically, the universe may have a preferred hand. Slightly right-handed, or slightly left. No one is certain yet which. What we are sure of is that spin is not a secondary property of the cosmos, not something that was added later, not an accident of circumstance. It is written into matter at the most fundamental level. Every particle, every electron, every proton, every tiny building block of everything you have ever touched carries something called spin. Not literal spinning, not the kind you can see, but a deep mathematical property, a kind of inner rotation that determines how the particle behaves, how it bonds, how it becomes part of a larger thing. Without it, chemistry doesn't work. Without chemistry, there are no molecules. Without molecules, no life, no breath, no sleeping body in a quiet room at night. The spin you don't feel is also the reason you are here to not feel it. Stay with that for a moment. Let the air fill all the way down and release it slowly, as if you're setting something gently down. Every part of you is built from particles that carry spin, not as a poetic idea, literally. Those spins follow strict rules. They determine how atoms bond, how molecules form, how your body holds together at all. And if you trace that chain backward, step by step, you don't arrive at something abstract. You arrive at the early universe, where those rules first took shape. The atoms in your hands, the electrons orbiting in the cells of your lungs, the iron turning slowly in your blood, spinning and still, at the same time as they have always been. Let that settle. Something is waiting at the edge of what we've just said. We've said that the universe was born with a lean, a slight asymmetry that allowed everything to move. But there is something even stranger waiting in that idea. If spin is built into every particle, if the universe has a preferred handedness, then maybe life itself was not free to choose its direction. Maybe the very shape of your DNA, that long, winding spiral inside every cell in your body, was nudged in its direction long before this planet existed. I want to be careful here. The exact origin of DNA's handedness is still an open question in science. Genuinely open, not just technically. There are good hypotheses. None of them are proven. But the possibility is real, that it was not chance alone, and not biology alone, but something older, written into the first preferences of matter. Did the spinning of this world make it possible for anything to be alive? Stay with me here. This one is strange, but worth it. Imagine a planet, a world roughly the size of Earth, orbiting a star at just the right distance. Not too hot, not too cold. A place where water might exist, where chemistry might work, where the conditions for something like life are technically present. Now imagine that planet has stopped spinning. One face locked permanently toward its star. Scorched, airless, blazing. 300 degrees, maybe more. The rock glowing faintly in the heat. The other face turned forever away. Frozen, lightless. Temperatures low enough that the air itself would solidify and fall to the ground like snow. And at the edge between them, a thin, permanent twilight zone where ferocious winds howl endlessly from the hot side to the cold. Not weather, a permanent wound in the atmosphere. There is no morning on that planet, no evening, no tide, no season, no gentle cycling of light and dark that a living thing could follow, could trust, could build itself around. That planet is not imaginary. We have found worlds like it, tidally locked, one face toward the sun, one face to the void. And so far, none of them look like good candidates for life. Now, turn your attention to the world you're lying on right now. It spins. And everything is different because of that. Start with something simple. The sun rises. That seems obvious, almost too small to mention. But follow what it actually means. When sunlight sweeps across the surface of a spinning world, it doesn't just illuminate. It heats one side while the other cools. And that difference, that temperature gradient, warm here, cool there, is all the atmosphere needs to start moving. Warm air rise. Cool air rushes in to fill the space. And because the Earth is spinning beneath that air, turning constantly eastward, the moving air curves. Not because anything is pushing it sideways, but because the ground beneath it is rotating, and the air carries the memory of where it came from. That curve is the reason hurricanes exist. It is the reason the jet stream exists, that great river of wind 7 miles above your head, that carries weather systems across continents. It is the reason the oceans have gyres, vast, slow spirals of water, some of them wider than continents, circulating heat from the equator to the poles, and cold water back again, like a slow planetary heartbeat. All of that, every storm, every current, every cloud, is spin, translated into weather. But the spinning doesn't stop at the atmosphere. It reaches down, through the crust, through the mantle, all the way to the heart of the planet, where liquid iron churns in slow, enormous rivers. That churning, driven partly by the planet's rotation, generates something invisible but essential: a magnetic field. It extends far out into space around us, a vast, invisible shield, like a bubble wrapped around everything we've ever known. And the sun is constantly trying to take it away. The sun breathes out, constantly, ceaselessly, a wind of charged particles, streaming outward at 1,000,000 miles an hour. If that wind were to reach our atmosphere directly, it would do what it did to Mars. Mars is what Earth could become. And I have never quite been able to stop thinking about that. It's not too far from the sun. A day on Mars is only 40 minutes longer than a day on Earth. It once had rivers. It once had lakes. There is evidence written in ancient rock formations that liquid water ran across its surface for millions of years. And then its interior cooled. The churning iron at its core slowed and stopped, and the magnetic field faded, the way a fire fades when the fuel runs out. Without the shield, the solar wind arrived, and over hundreds of millions of years, it stripped the Martian atmosphere away, molecule by molecule, like the wind stripping paint from an old wall. The rivers dried. The lakes evaporated. The air thinned to almost nothing. What's left now is a cold, dry, silent desert, with a sky the color of a bruise. Earth's magnetic field is still running, still spinning, still pushing the solar wind aside. And on the nights when that wind is strong enough to press against the field and make it shimmer, we see it from the ground as something achingly beautiful. The aurora. Those soft green and violet curtains near the poles, the ones that make people travel thousands of miles just to stand in the cold and look up, are the light of the solar wind entering at the seams of our magnetic shield, where the field is thinnest. They are not just beautiful, they are proof that the shield is working. A reminder, written in light across the sky, that this spinning planet is still protecting everything living on it. I remember reading once, late at night, later than I should have been awake, that the aurora had been visible as far south as Rome in 1909. Not an anomaly, just the sun being louder than usual, pressing harder on the field. I spent the rest of that night looking out the window at the unremarkable dark, knowing none of it was visible from where I was, and somehow feeling it anyway. And there is one more thing the spin does. Quieter than weather, quieter than magnetic fields, but in some ways the most intimate of all. Every living thing on Earth, every plant, every animal, every single cell in your body carries a clock. Not a clock you built, not one you chose. A molecular clock, woven into the chemistry of life itself, that runs on a rhythm of almost exactly 24 hours. It tells your body when to release certain hormones and when to hold them back, when to run your immune system at full strength and when to let it rest, when to consolidate memories from the day and file them away as you sleep. It tells the tree outside when to open its leaves in the morning. It tells the bird when to begin its migration. It tells the flower when to bloom. All of them synchronized, all of them quietly entrained to the rotation of a planet that has been spinning for 4.5 billion years. Life didn't just survive on a spinning world. Life organized itself around the spin, built its rhythms into the spin, learned to trust it, learned to depend on it so completely that the spin is now inside us, ticking away in every cell, every night, every moment of rest. Even now, right now, this moment, let the breath move on its own. Let the quiet settle around you. That tiredness you feel, the one that brought you here, to this quiet hour, to the edge of sleep, is your body following a rhythm that was older than your species before you were ever born. The spin of this world made the morning. The spin made the weather. The spin made the shield that kept the air from disappearing. And the spin made the dark. This particular darkness, this particular stillness that your body has been waiting for all day. You are not fighting the universe right now. You are moving with it, exactly the way it's always been. But here, right here, just before sleep takes you, there is a thread I want to follow a little further. We've talked about spin making life possible, about spin making weather and shields, and the rhythm your cells have followed since before you were born. All of that happens at ordinary speeds, human speeds, planetary speeds. But what happens when something spins much, much faster? Faster than a planet, faster than a star. Fast enough that the spinning itself starts to drag at the fabric of space and time, pulling it along the way a spoon dragged through honey pulls the honey into a slow curl. Because rotation, at extreme enough scales, does something that should feel impossible. It warps the geometry that time runs through. Not spin alone, but mass and motion together, concentrated. And spin is both of those things at once. Can the act of spinning reach into the geometry of time and pull? Imagine a perfectly still lake. Not a ripple, not a breath of wind. The surface so flat it looks more like glass than water. Now lower a sphere into it, slowly, gently, and set it spinning. Watch what happens to the surface. The water near the sphere doesn't just move outward. It begins to rotate, pulled in a slow circle by the turning of the thing at the center. The further you go from the sphere, the gentler the pull. But it's there, even far from the sphere. The water is no longer perfectly still. Here's the strange part. Replace the lake with space-time. Replace the sphere with the Earth. This is not a metaphor. This is what actually happens. Someone once spent years tracing the mathematics of how mass and motion shape the fabric of space and time, not as separate things, but as a single woven surface, something like that lake that can be stretched and curved and if the right kind of object is spinning fast enough, dragged. The Earth is spinning, and as it spins, it pulls space-time around with it, the way a spoon dragged slowly through honey, pulls the honey into a slow curl behind it. The effect is almost unimaginably small at Earth's speed. We send a satellite into orbit, carrying 4 gyroscopes, each one so perfectly spherical that if you scaled it up to the size of the Earth, the highest mountain on its surface would be barely 8 feet tall, just to measure it. The satellite orbited for a year, watching, waiting, and the gyroscopes moved, not because anything pushed them, but because space-time itself had shifted beneath them. The Earth's spin had dragged the geometry of space, tilted it, just barely, by an amount smaller than the width of a human hair divided by 1,000. And the measurement matched Einstein's equations, almost perfectly. That experiment didn't just confirm a theory. It confirmed that the universe is the kind of place where even a planet, gently turning in the dark, leaves a mark on the shape of time. Now take that principle and make it extreme. When a star many times the size of our sun reaches the end of its life, it doesn't fade. It collapses. Everything that was once spread across millions of miles falls inward in seconds, crushed so completely that protons and electrons are squeezed together into neutrons, and what remains is something barely 12 miles across, but heavier than our entire Sunday. And it inherits all the spin of the star that made it. Think about that ice skater one more time. Arms out, spinning slowly. Arms pulled in, spinning in a blur. Now collapse them down to the size of a city. These objects spin hundreds of times every second. Not once a day, not once an hour. Hundreds of complete rotations every single second. And they are so dense, so gravitationally powerful, that the frame-dragging effect, that gentle honey curl the Earth creates, becomes something violent. Near one of these spinning objects, time itself slows down. And I want to be precise here, this isn't a metaphor. Measurably, verifiably, if you had a clock there and a clock here, and you compared them later, they would disagree. The one closer to the spin would have counted fewer seconds. Motion and gravity slow time, and spin is both motion and gravity at once, concentrated. The satellites that your phone uses to know where you are, they orbit thousands of miles above the Earth, moving fast, in slightly weaker gravity than the surface. Both of those factors affect how their clocks run. Not by much, by about 38 microseconds a day. But 38 microseconds, uncorrected, accumulates. Left alone for a single day, the error would place you several miles from where you actually are. Every map on every phone in the world quietly corrects for the fact that time runs differently, at different heights, at different speeds, in different depths of gravity. Einstein's equations are not theoretical tools sitting in a journal somewhere. They are running right now in the background of the device that probably brought you here tonight. But if all of that is strange, a neutron star bending time, a satellite clock drifting, then what happens at the far end of the scale? What happens when you take something that spins and make it not just very fast, not just unimaginably fast, but as fast as the physics of our universe will allow? You get something that has no surface, no edge, no place to stand. A spinning black hole. Close to it, not inside it, just close, there is a region of space where something extraordinary is true. Nothing can stand still. There's no wind, no current, nothing pushing you. But because space-time itself is rotating, and you are inside it, like being a leaf dropped into a whirlpool, you don't choose to rotate. Rotation is simply what space is doing there, and you are made of space. Inside that region, past and future begin to lose their edges. The mathematics that describes it, and this is genuinely one of the places where mathematics outpaces our intuition, allows for paths through space-time that loop back. Paths where a thing could, in principle, arrive before it left. Whether anything real can ever travel those paths, whether time travel of that kind is physically possible or only mathematically permitted, no one knows. That is an honest answer. The equations allow it. The universe has not confirmed it, and perhaps it never will. But the possibility exists, not as science fiction, not as fantasy, as a genuine, open question, sitting at the intersection of rotation and time. Let your body go where it wants right now. In and out. Feel the floor beneath you, solid and still. You are not near a spinning black hole. Your time is running at its full, unhurried pace. Every second here is a full second. Not stretched, not slowed, not pulled sideways by a gravity you can't see. And yet, you are not exempt from it. You are made of matter, and every piece of matter has mass. En masse, according to the same equations that predicted all of this, curves space-time. Just by existing, you are bending the geometry of the universe around you. Immeasurably, infinitesimally, but not by zero. The universe, in some tiny and technical sense, is not exactly the same shape as it would be without you. And as you breathe, as you lie here, turning with the planet, carried by the solar system, swept along by the galaxy, your presence leaves its whisper in the fabric of everything. Hold that thought gently as sleep comes closer, because there is something waiting just beyond it, something that follows naturally from all we've said. If spin shapes the geometry that time runs through, and the universe has been spinning since the very beginning, then perhaps time itself is not a river flowing in one fixed direction. Perhaps time is something the universe is still deciding on, something still being shaped by the turning of everything, right now, even as you sleep. If spin is the thing that shapes time, then what is keeping the spin alive? Think about the last time you wore a watch. Not a phone, an actual watch with a face and hands. There's a second hand, moving in its small, steady arc. Tick, tick, tick. You probably never wondered what it was measuring. A second is a second. It's the fabric of schedules and appointments, and the ordinary sense that time is passing. But here is the quiet secret inside that tick. A second is not defined by the movement of hands. It is not defined by the turning of the earth. A second is defined by an atom inside the most precise clocks ever built. Instruments so accurate, they would neither gain nor lose a single second over hundreds of millions of years. There is a single species of atom, and it vibrates. Not randomly, not approximately, at a frequency so fixed and so perfectly reproducible that every second on every clock on every network in the world is ultimately anchored to it. And what drives that vibration? The spin of its electrons. Quantum spin, not the physical spinning of a top, but a deep intrinsic property of the particle itself, determines exactly how an electron behaves inside a magnetic field, exactly which energy levels it can occupy, and exactly what frequency of light it releases when it flips from one state to another. That flip, that tiny quantum somersault, is what a second is made of. Nearly 10 billion of them, one after another, every second of your life. So when you ask, what controls time? The honest answer begins not with planets or galaxies, but with something you cannot see, cannot touch, cannot hold. A quantum property buried inside the smallest pieces of matter, ticking faithfully at the bottom of everything. And here's where it gets interesting, because that same idea doesn't stay small. The Earth spins once every 24 hours, and for most of human history, that was the definition of a day. The sun rises. The sun sets. One complete rotation. One unit of lived time. But the Earth's spin is not perfectly steady. It is, ever so slightly, slowing down. The moon is seen to that. Its gravity reaching into our tides, extracting a whisper of rotation with each passing year. And so a strange thing became necessary. Our atomic clocks, calibrated to the quantum spin of electrons, utterly indifferent to tides and moons, run at one speed. The Earth runs at another. And very occasionally, when the gap between them grows large enough to matter, the world's timekeepers add a single extra second to the calendar. A leap second. The clocks pause for exactly one heartbeat and wait for the planet to catch up. I find something unexpectedly moving about that. Though I'm not sure moving is even the right word. It's more like a small, quiet shock that there exists a committee of people sitting somewhere reading very careful measurements, whose job is to notice that the Earth is running slightly behind the atom and to insert a second of grace. so that human time stays tethered to the world it was born on. We built clocks that outran our planet. I once read that on certain years, a single second is quietly added to the end of December. Not announced, not celebrated, just inserted while most people are asleep. And then, gently, we slow them down to stay with it. If you push that scale even further past the planet, past the atomic clock, from the planet to the sun spins too, but not the way a solid ball spins. It is made entirely of gas, and different parts of it rotate at different speeds. The equator turns faster than the poles. The surface moves differently from the deeper layers beneath. And that difference, that constant twisting of one layer against another, generates the sun's magnetic field. Not a clean, stable field like a bar magnet. A writhing, tangled field that stretches and kinks and occasionally snaps, releasing in seconds the energy of millions of nuclear bombs hurled outward into the solar system as a wall of charged particles and radiation. When those walls reach Earth, when the sun's tangled spin crashes against our planet's quieter one, we sometimes see them in power grids flickering, in satellites briefly confused, in the aurora burning wider and further south than usual. The sun's spin is not distant from your life. It occasionally reaches out and touches it directly. We're not done going outward yet. To the galaxy. The Milky Way is rotating. Not quickly, not in any way you could perceive in a lifetime, or 1,000 lifetimes, or 10,000. One full rotation takes roughly 230 million years. The last time our solar system was in this same position in the galaxy, facing the same direction, carrying the same stars in its neighborhood, the dinosaurs had not yet appeared. That was the previous galactic year. The one before that was before complex life existed on land. Go back 4 galactic years, and the Earth itself had barely formed. We are, in galactic time, very young. And the galaxy has been keeping its own time, its own slow, enormous clock, for all of it. From electron spin to atomic second, from atomic second to planetary day, from planetary day to galactic year. Every clock we have ever trusted, every rhythm we have ever used to measure the passing of things, turns out to be a rotation. And none of them need to be maintained. What I keep returning to, and what I find genuinely hard to accept at face value, is that none of it needs to be maintained. No one is keeping the atoms spinning. No one is keeping the Earth turning. No one is keeping the galaxy in its long, slow arc. They continue, because nothing has stopped them. In a universe with no friction, no resistance, no wall to run into, motion set in place billions of years ago, simply continues. The universe is not being wound. It was wound once, at the beginning, in whatever strange first moment gave rise to angular momentum, and it has been unwinding perfectly ever since. Like a music box that was wound before you were born, and will still be playing long after you are gone. You arrived in the middle of the song. No need to hold any of it. Just notice it, in and out. The rhythm of your breath is yours, but the atoms that move with it, the electrons spinning in every molecule of air entering your lungs, are carrying a rotation that predates this planet. Somewhere in the architecture of what you are, the universe is still keeping time. Quietly, without effort, without needing anyone to notice. It simply continues. As you will, for now, continue. Into the dark and into sleep. But before you go completely, one thought to carry with you. We have said that spin marks time, that it is the mechanism at the bottom of every clock, every second, every rhythm we have ever trusted. That spin shaped this planet into something livable. That spin bent space-time around massive objects. That spin is the silent mechanism running every clock in the universe. But there is a question underneath all of that. One that does not ask how the spinning continues, but what it is, exactly, that spin is spinning through. Because galaxies are moving apart from each other, the universe is expanding. And if the universe is expanding, if the very space that everything is spinning inside of is getting larger, then what does that mean for all this motion we've been following? What happens to a spin when the thing it's spinning in keeps growing? Did the universe begin because something that was perfect broke? I want you to think about a pencil. A perfectly sharpened pencil, balanced on its tip. In theory, purely in theory, if you placed it precisely enough, if the surface were perfectly flat, if the air were perfectly still, it would stand there forever. Perfectly balanced, perfectly symmetrical, pulling equally in every direction, with no reason to fall one way or the other. But it falls. It always falls. The universe may owe its entire existence to the same moment, to a pencil tipping. Not a real pencil, but a symmetry. A perfect, beautiful, total symmetry that the universe once had. And then, in the very first fractions of its very first second, lost. In the beginning, if beginning is even the right word for something that existed before time had a direction, the forces that govern everything were not four separate things. There was no gravity pulling separately from electromagnetism, no nuclear forces distinct from one another. There was one thing, one unified force, perfectly balanced, holding everything together in a state so symmetrical that no part of it had any reason to behave differently from any other part. And then the universe expanded. It cooled, the way a breath cools when it hits cold air, the way water cools until it becomes ice. And as it cooled, the symmetry cracked. Gravity peeled away from the rest. Then the other forces separated from each other, own by own, like fingers slowly releasing their grip. And in each separation, in each small breaking, tiny imperfections appeared, not flaws. Gifts. Because a perfectly symmetrical universe is also a perfectly motionless one. If everything pulls equally in every direction, nothing moves. If every possibility is exactly as likely as every other, nothing chooses. If matter and energy are distributed with absolute perfection, gravity has nothing to work with. No clumps form, no stars ignite, no planets collect themselves from spinning dust. Just a vast, even featureless fog, spreading outward forever, into a darkness that never becomes anything at all. It is the imperfection that saves everything. We mentioned earlier the oldest light in the universe, that ancient glow still passing through you right now. It shows this directly, and more clearly than I expected when I first read about it. When instruments sensitive enough to hear a whisper across the entire sky mapped that ancient light in extraordinary detail, they found it was almost perfectly uniform. Almost. There were tiny ripples, temperature variations so small they amount to less than 1 part in 100,000. Barely anything, hardly a flaw at all. And yet those barely anything ripples are the reason you exist. In the places where the early universe was ever so slightly denser, gravity pulled just a little harder. Matter drifted toward matter, slowly, over millions of years, the way dust gathers in the corner of a room. And the gathering became clouds. The clouds collapsed. The collapsing created heat. The heat ignited the first stars. From a ripple, smaller than 1 part in 100,000, the entire visible universe, all its galaxies, all its stars, all its spinning, breathing, living worlds, every single one of them descended from an imperfection so small it barely deserves the word. But the breaking went deeper than that. When matter first appeared, in those earliest, hottest moments, it did not appear alone. For every particle of matter, a particle of antimatter was born alongside it. Perfect mirror twins. One positive, one negative, equal in every measurable way. And when matter meets antimatter, they annihilate each other. Both disappear, converted entirely into light. If the universe had been perfectly symmetrical, if matter and antimatter had been born in exactly equal amounts, they would have cancelled each other out completely. Every particle consumed by its mirror, everything becoming light, and the light itself thinning and spreading and cooling into nothing. But it wasn't perfectly equal. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. One extra out of 1,000,000,000. The annihilation happened. The 1,000,000,000 pairs destroyed each other, flash after flash, filling the young universe with light. And the one that was left over, that single surviving particle out of every 1,000,000,000, drifted on. all the matter in the universe today, every star you have ever seen, every ocean, every mountain, every sleeping body in every quiet room tonight, is made from those remainders, the leftovers of an almost perfect cancellation. You are the one that survived, out of 1 billion. And here is the part I keep returning to, the part that doesn't sit still. Even the direction of time, the reason yesterday is fixed and tomorrow is open, the reason you remember the past and not the future, may be a consequence of broken symmetry. The fundamental laws of physics at the particle level are almost entirely reversible. A film of 2 particles colliding looks the same played forward or backward. The physics doesn't care which direction time is running. And yet time, in our experience, moves only one way. Things fall but do not unfall. Ice melts but does not unmelt. We grow older and not younger. The reason for that arrow, the reason time flows forward, appears to be that the universe began in an extraordinarily ordered state. Low entropy, high symmetry, everything at the start arranged in a way that could only become more disordered. Like a room that starts perfectly tidy, every book in place, every surface clear, and then is lived in. The tidiness was the beginning. The disorder is time. We are not moving through time so much as we are living the universe's slow drift, away from the perfect order it started with. Every moment that passes, every breath, every heartbeat, every thought forming and dissolving, is a small step further from that first perfection. And in that stepping away, in that beautiful, irreversible unfolding, everything that has ever happened has been made possible. Something in you already knows how to be quiet. Feel the room around you, the air, the dark, the quiet weight of your own body. You are made of matter that survived an annihilation, built from ripples barely worth measuring, shaped by forces that cracked apart before the first star was born. The imperfection that made you possible was written into the universe before this planet existed. And the time you are living right now, this moment, this breath, this edge of sleep, is part of that same slow drift, away from the beginning. You are not separate from the unfolding. That sounds abstract, but here's the concrete version. The entropy in your body right now is measurably increasing. The same process running in every star is running in you. Not a metaphor, a direction of energy flow, measurable in any physics lab. Rest here for a moment, because what comes next reaches further still, into a mystery that took most of the 20th century to even recognize. We have said that broken symmetry allowed matter to form, that imperfection let gravity work, that the universe structured itself from its own unevenness. But when astronomers actually measured how fast galaxies spin, how fast the stars at their edges move compared to the stars at their centers, They found something that didn't fit any of this. Something was wrong. Not a small discrepancy. Not a rounding error. The galaxies were spinning far too fast. Fast enough that, by everything we understand about gravity, they should have torn themselves apart long ago. And yet there they are, intact, turning, beautiful, held together by something we have never seen, never touched, and still cannot name. What is the invisible thing that holds a spinning galaxy together when all the physics says it should have flown apart? Let me describe something to you. You've seen a spinning top, the old kind, wooden, the kind a child sets going on a table and then steps back to watch. As long as it spins fast enough, it holds itself upright, defying gravity, perfectly balanced on its tip. But there's a limit. Spin it too fast, and the centrifugal force outward overcomes the material holding it together. It shatters. Every spinning object has that limit, a point where the outward pull of rotation exceeds whatever force is keeping it whole. Galaxies have the same problem. A spiral galaxy, that slow, gorgeous wheel of 100 billion stars, is spinning. Not gently. The stars at its outer edges are moving at hundreds of thousands of miles per hour. And when astronomers did the mathematics, when they counted all the visible stars, all the gas, all the dust, and calculated how much gravity that mass could produce, they found something deeply wrong. There wasn't nearly enough. By everything we understand about gravity, the outer stars of a spiral galaxy should behave the way the outer planets of our solar system do. Slower, more loosely bound, gradually drifting. Instead, they move at almost the same speed as the stars near the center. Fast, committed, as if something is holding them in. Galaxies are spinning at speeds that should tear them apart. And they have been doing this, unchanged, for billions of years. The first person to take this seriously, to look at the numbers and refuse to explain them away, was an astronomer working quietly in the 1970s, measuring the rotation of galaxies one careful observation at a time. She plotted the speeds of stars at different distances from their galactic centers, expected a downward curve toward the edges, got a flat line instead. Not a slight flattening. Flat, as if the stars near the edge had no idea they were supposed to be slowing down. She checked it again, checked it in another galaxy, then another, and another. Every spiral galaxy she measured told the same story. The visible matter in a galaxy. Every star you can see, every cloud of gas you can detect, is not the majority of what's there. Something else is. Something enormous. Something that has no face, no light, no signal of any kind. Something that exists only in the way it pulls. We call it dark matter, though the name is almost misleading. It isn't dark the way a shadow is dark, or the way a moonless night is dark. It is dark the way a thought is dark, present, real, shaping everything around it, and yet entirely invisible to every instrument we have ever built. It does not glow. It does not reflect. It does not absorb light or emit it. It passes through ordinary matter, through walls, through planets, through you, without any interaction at all. The only thing it does is gravitate. And that is enough to hold a galaxy together. Picture each spiral galaxy sitting inside an enormous, invisible sphere. A halo of dark matter extending far beyond anything you can see, far beyond the outermost stars, out into the dark space between galaxies. That halo is the scaffolding, the visible galaxy, the beautiful spiral, the glowing arms, is just the light clinging to the inside of an invisible structure, far larger and more massive than itself. The Milky Way's visible disk, the part we can see, the part containing our sun, extends perhaps 50,000 light-years across. The dark matter halo surrounding it may extend 10 times further, perhaps more. We are living inside the visible fraction of something much larger that we cannot see at all. There is a way we know this is real, not from measuring things directly, but from watching what happens to light. When light from a very distant galaxy travels toward us and passes close to an enormous concentration of mass along the way, even invisible mass, the light bends. Space-time is curved there, and the light follows the curve, the way a river bends around a mountain, even though the mountain is hidden underwater. So the distant galaxy, seen from Earth, appears smeared, stretched into arcs, or doubled, or ringed with halos of its own light. The distortion maps the invisible mass. The bending of light draws the outline of something that refuses to be seen any other way. We have found galaxy clusters where two enormous systems collided, hundreds of galaxies slamming into hundreds of galaxies over millions of years. In the aftermath, the hot gas ordinary matter lagged behind, slowed by the collision. But the gravitational mass, as mapped by the bent light of galaxies behind it, had sailed straight through, unbothered, unaffected by the impact. Because dark matter doesn't interact with ordinary matter, it passed through the collision, the way a ghost passes through a wall. And in doing so, it separated from the gas, leaving behind a visible map of where the invisible mass had gone. It was the closest thing to a photograph of dark matter that has ever been taken. And yet, what it actually is, we still do not know. There are experiments running right now, buried deep underground to shield them from the noise of the ordinary universe, watching for a single dark matter particle to brush against an ordinary atom and leave a trace. Just one interaction, one faint recoil, enough to tell us something about what this thing is made of. None of them, so far, have found it. The detectors waited in the dark, patient, listening. There is something I find oddly companionable about that. Those instruments, buried under a kilometer of rock somewhere in a mountain, running in total silence, waiting for a particle that has never once confirmed it exists. I'm not sure that is so different from a lot of things we do. Listening carefully for something we're not quite certain is there. Some physicists wonder if our understanding of gravity itself needs to change, if perhaps dark matter is not a substance at all, but a sign that gravity behaves differently at galactic scales than it does here, in the quiet physics of our solar system. That is an honest possibility, and no one has ruled it out. What is certain is this: 5 times more of the universe is invisible than visible. Everything you have ever seen, every star in the night sky, every photograph of a galaxy, every glowing nebula, is a small, bright minority inside an enormous dark majority that we cannot yet read. The universe is mostly something else, and we are living inside it, warmed by our small local star, held in our orbit by our small local gravity, looking out at the faint light of the visible fraction and calling it the cosmos, when what we are really seeing is the glow on the surface of something far deeper and far stranger than we have yet imagined. Sink a little deeper into wherever you're lying. The dark around you tonight, the ordinary dark of a room at night, is the most familiar version of something the universe has always known better than we have. Most of existence is quiet, invisible, felt only in what it holds together. That picture sounds almost too quiet to be real, but this is how we detected it, not by seeing dark matter directly, but by measuring what rotating galaxies should do and watching them refuse to obey. It simply holds, the way the best things often do. But here is the thought that carries you into what comes next. We have been talking about spin at the scale of galaxies, about the rotation of enormous things, things measured in light years, things older than our Sunday. But what if that same rotation, that same ancient cosmic preference for one direction over another, reached all the way down? Not to planets, not to atoms, to life, to the spiral inside a single cell in your body, winding in one direction and not the other, for a reason that may have been decided long before this world existed. Did the universe's ancient preference for one direction quietly decide the shape of every living thing? Hold out your hands for a moment. Both of them, palm up. Look at them. They are almost identical. The same bones arranged in the same order, the same tendons running beneath the same skin. And yet they are not the same. They are mirror images. You cannot lay one perfectly on top of the other and have them match. No matter how you rotate them, no matter how you flip them, left and right will not become identical. They look the same. They function the same. But they are fundamentally, irreducibly different. Molecules can be the same way. Two molecules, built from exactly the same atoms, bonded in exactly the same order, can exist as mirror images of each other, left-handed and right-handed. Same ingredients, same structure, different orientation in space. In a laboratory, when you synthesize these molecules from scratch, with no external influence, no preference imposed, you get roughly equal amounts of both, left and right, balanced, as you'd expect from a universe that has no favorite. But life is different. Every living thing on Earth, without exception, from the smallest bacterium to the largest tree to every cell in your body, uses only one hand. The amino acids that build every protein in your body are left-handed. All of them. The DNA coiled inside every one of your cells spirals to the right, always. Not mostly left, not predominantly right, exclusively. Life made a choice, or something made it for life, and has held to that choice across 4 billion years, across every species that has ever lived, without a single exception. And no one fully knows why. The question that haunts biologists and physicists alike is whether this was a random accident, an early coin flip that happened to land on one side, and then locked in forever, or whether the universe itself was already leaning that way before life began. The clue that tilts toward the second answer is light. Light, it turns out, can spin. Not the light itself moving in a spiral, but the wave of it, the electromagnetic oscillation, can rotate as it travels, clockwise or counterclockwise, right-handed or left-handed. When light from a massive, hot, young star passes through a cloud of magnetic dust, the kind of cloud that drifts between stars, ancient and cold, the dust filters it. One-handedness passes through more easily than the other. What emerges on the other side is circularly polarized light. Light that spins preferentially in one direction. And when that light falls on amino acids, when it lands on the raw chemical ingredients of life floating in space, it does something extraordinary. It destroys one hand more than the other. Left-handed light preferentially breaks apart right-handed molecules. Right-handed light preferentially breaks apart left-handed ones. After enough time, after the light of enough ancient stars has passed through enough magnetic clouds and fallen on enough drifting chemistry, an imbalance accumulates. Not a large imbalance, a very small one, but enough. In 1969, a rock fell out of the sky over a town in Australia. It landed in the early morning, breaking into pieces across a wide area of farmland, and it smelled, oddly, unmistakably, like methylated spirits. It was a meteorite, ancien, older than the Earth, and inside it were amino acids, more than 70 different kinds, some of them not found in any living organism on Earth, some of them familiar, all of them preserved in the rock since before our solar system existed. When scientists examined the handedness of those amino acids, they found a slight excess. Not 50-50. Not random. A small, measurable lean toward left. The universe had already made its preference known, before this planet had even formed. Life, arriving later, may simply have followed the direction. The chemistry was already pointing. There is a deeper layer still. One of the forces that governs the behavior of particles, the force responsible for certain kinds of radioactive decay, for how neutrons transform inside atomic nuclei, does not treat left and right equally. This was discovered in the 1950s, in a careful and elegant experiment that the physics community initially resisted, because the idea that nature could have a handedness felt philosophically uncomfortable. If the universe is governed by laws, shouldn't those laws look the same in a mirror? The experiment said no. The force does not treat left and right equally. It has a preference, clear, measurable, fundamental, and every neutrino ever observed spins in only one direction, left-handed always, without exception. The universe, at its most fundamental level, is not symmetrical between left and right. And that asymmetry, that ancient preference written into the deepest laws of physics, may be the same preference that shows up in the shape of your DNA. From the behavior of a particle, to the spiral of a molecule, to the double helix inside every cell in your body. The same lean, the same handedness, echoing across every scale. There are places in the sky right now where new stars are being born. Vast clouds of gas and dust, slowly collapsing under their own gravity, beginning to spin, beginning to heat. And inside those clouds, floating between the grains of dust, drifting in the cold dark between future stars, are organic molecules, carbon chain, simple sugars, the precursors of amino acids, instruments that see in infrared, wavelengths of light too long and too cool for human eyes, have detected them there. Pre-biological chemistry, forming in the dark, long before any planet exists to receive it. And the light that bathes those molecules, light from the young stars forming nearby, polarized by the magnetic dust of the cloud, is already selecting, already laning, already nudging the chemistry toward one hand, before any world has formed, before any ocean has gathered, before anything has tried to be alive. The direction of life, it seems, is not decided by life. It is inherited, or so the evidence suggests, though exactly how far back that chain reaches is something science is still carefully tracing. Passed down, possibly from the spin of the galaxy to the twist of magnetic dust, from the polarization of starlight to the handedness of molecules, from the molecules to the first self-replicating chains, from those chains to every organism that has ever drawn breath, including you. Feel that for a moment. quietly, without trying to think it through. The spiral inside each of your cells is not an accident of biology. It is a continuation. Though I want to be careful not to overstate this, because the full chain I'm about to describe is still being worked out. The individual steps are measured. The full connection from cosmic asymmetry to DNA handedness has not been cleanly proven. It's more like the signposts point in one direction, a very long chain of inheritance that reaches back through the history of this planet, back through the chemistry of the early solar system, back through the polarized light of ancient stars, back to a preference written into the laws of physics themselves, in the first moments of the universe. You are twisted in a particular direction because the universe is twisted in a particular direction. Not poetically, or not only poetically. The molecules are real. The handedness is real. The exact origin of that preference is still an open question in science. But what is not in question is that the preference exists. The nod is doing the resting for you. In and out. Feel the weight of your hands, those left and right hands that mirror each other, but can never be made to match. Inside each of them, the proteins folding in your cells are all bending the same way, left as they have always bent, as everything living has always bent. And the DNA winding in each nucleus spirals to the right, the way it has since the very first cell, following a direction older than this world. In some very literal sense, not only a poetic one, you are not separate from the universe's handedness, which means the same asymmetry that shaped the early universe is physically present in the molecules doing the work of keeping you alive right now. Let that sit with you as sleep comes. And just before we let the story grow quiet, there is a small thought I keep returning to. We have followed spin from the first second of the universe all the way into the spiral of your DNA. We have watched it mark time, shape planets, hold galaxies together, and write the handedness of life. But nothing spins forever. The Earth is slowing. Galaxies are drifting apart. Even the most furiously spinning objects in the universe are, over vast time scales, giving their rotation away to tides, to gravity, to the expanding emptiness between things. And so the question that waits at the edge of sleep tonight, the last quiet question, is this: will the universe one day forget how to spin? And if it does, what will be left? What happens to a spin that has nowhere left to go? Think about a bell. A large one. The kind that hangs in an old stone tower, cast from bronze, older than anyone alive. When it's struck, the sound fills everything. Enormous, resonant. The kind of sound you feel in your chest before you hear it with your ears. And then, slowly, it fades. Not all at once. The note lingers, gets quieter, spreads outward into the air until it's too faint to hear, though the molecules of air are still carrying it, still passing it along, far beyond the range of any ear. The sound doesn't stop. It just spreads thin. The universe is a bell that was struck once, a very long time ago. And everything we've been talking about tonight, every spin, every orbit, every galaxy slowly turning, is that note, still sounding, still spreading, getting quieter with every passing billion years. Nothing in the universe spins forever. The Earth is slowing, 1.5 milliseconds per century, the moon pulling patiently at our tides. But follow that process far enough forward, far beyond any human timescale, far beyond the existence of this species or this planet, and something extraordinary waits at the end of it. There will come a time, billions of years from now, when the Earth and the moon face each other permanently. The same face of the Earth always turned toward the moon. The same face of the moon always turned toward us, which it already does. Two locked dancers, neither turning away. The tidal exchange between them finally settled into a stillness that took billions of years to reach. No more sunrise on half the world. No more tide rolling in and pulling back. No more daily rhythm inherited from the spin. Just one long day on one side and one long night on the other, forever. The same slowing is happening throughout the solar system, and has already happened in places. Mercury is nearly locked. Venus rotates so slowly and in the wrong direction that the sun rises there in the west, and a single day lasts longer than a year. Spin, at the planetary scale, is already winding down. And at the galactic scale, the story is the same, just slower. Galaxies that formed as tight, fast-spinning spirals gradually lose their shape over billions of years. When two galaxies pass near each other, even if they don't fully collide, gravity reaches between them, exchanging angular momentum, the way two spinning tops affect each other when placed close together on a table. The spiral arms loosen, the tight structure softens. Over enough time, what was once a beautiful pinwheel becomes a diffuse, roughly spherical cloud of old stars, an elliptical galaxy barely rotating at all. The Milky Way and the galaxy nearest to us are already on a path toward each other. Not a crash, more like a slow, inevitable embrace. Their outer halos are already beginning to interact. In a few billion years, they will pass through each other. The stars, widely spaced as they are, will mostly not collide, but the structure of both galaxies will be disrupted. And over hundreds of millions of years, the two spirals will merge into a single, slowly rotating ellipse. The grand spiral arms of the Milky Way, the ones that took billions of years to form, the ones our sun has been sailing through for its entire existence, will be gone, dissolved into a shape that barely remembers it ever turned. This is the part I think about most when I think about spin. Even as spin fades at the scale of planets and galaxies, at smaller scales, it does something different. When a massive star reaches the end of its life, and its core collapses, all the rotation that was spread across millions of miles of stellar gas is suddenly compressed into something the size of a city. The skater pulling in her arms. Again. One final, extreme time. What remains spins hundreds of times per second. Not once a day. Not once an hour. Hundreds of complete rotations, every single second, and beaming a pulse of radiation with each turn, so precise and regular that when astronomers first detected one, they briefly wondered if it was a signal. Not a natural phenomenon, a message. It was not a message. It was a dying star, rotating with a precision that puts every clock we have ever built to shame. Those objects slow too, eventually, radiating their rotation away as waves in space-time itself, invisible ripples spreading outward at the speed of light, carrying the last of their spin into the dark. And then there are black holes. A spinning black hole is, in some ways, the final form of rotation in the universe. Nothing else takes spin to such an extreme. A black hole can rotate at a significant fraction of the speed of light. The mathematics allows it, and observation confirms it. And as it spins, it does not keep that spin to itself. It drags space-time around with it. That same honey curl we talked about earlier, but now so extreme that even the region of space outside the event horizon is forced to rotate. But even black holes are not permanent. They leak, slowly, inconceivably slowly, through a process so subtle that it was considered almost purely theoretical for decades after it was first described. Empty space, it turns out, is not truly empty. It is filled with pairs of particles, matter and antimatter, flickering in and out of existence at the quantum level, constantly being born and annihilating each other in timescales too small to measure. Near the edge of a black hole, occasionally, one of those pairs forms at just the wrong moment. One particle falls in, the other escapes. The black hole, in order to conserve energy, loses a tiny fraction of its mass. Over timescales so vast they make the current age of the universe feel like a morning. The black hole evaporates. Its spin, carried away in radiation and gravitational waves, disperses into the expanding dark. And then, further still, past the death of black holes, past the decay of the last protons, past every structure that could be called a thing, the universe arrives at a state that has a name. Heat death. Not heat in the sense of warmth, but heat in the thermodynamic sense. A state of perfect equilibrium. Every particle at the same temperature. Every region of space indistinguishable from every other. No gradients. No flows. No reason for anything to move in any direction rather than any other. The bell, at last, has spread its notes so thin that no instrument could detect it. That sounds like it should be the end of the story, but it isn't. I want to warn you, is going to sound stranger than it should. Angular momentum cannot be destroyed. This is not a hopeful sentiment. It is a law. In a closed system, and the universe is the ultimate closed system, angular momentum is conserved, always, without exception. The spin does not stop. It spreads. It dilutes. It distributes itself across an ever larger volume of space, until it becomes imperceptible, until no instrument, no mind, no observer could detect any rotation anywhere. But mathematically, in the cold, patient language of physics, angular momentum is conserved. It doesn't vanish. Whether that means it is truly still there depends on what you mean by there. There is no instrument that could detect it. There is no observer who could feel it. And yet the equations say the total rotation of the universe, whatever it was at the beginning, is the same at the end. Spread so thin it has no face. Present the way a number is present, even when nothing is counting. Let your hands go soft, long and slow. Feel the rise and fall of your chest. You are breathing in a universe that is, on the grandest scale, winding down. Every rotation you are part of, the Earth turning beneath you, the solar system curving through the galaxy sweeping through the local group, is part of a note that is slowly, gently, over time scales so large they have no human name, fading. But you are inside the loudest part of the note. Right now, tonight, this breath. The stars are still burning. The galaxies are still turning. The universe is still full of structure, and gradient, and motion, and the extraordinary improbable fact of living things, lying in the dark, and wondering about it all. The silence that will one day come is unimaginably far away. And this moment, this warm, spinning, living moment, is not close to it. Let it be enough, just knowing it. Before we let go completely, there is a light I keep seeing left on in the distance. We have said that spin cannot be destroyed, that the memory of every rotation is preserved in the geometry of the universe. And we have said that you are here, conscious, breathing, wandering, inside a universe that has been spinning since before time had a direction. So here is the question that I cannot fully answer, and I'm not sure anyone can. Is it possible that what we call awareness, this quiet, wandering presence you carry inside you, is the universe's way of noticing its own motion? Not a poetic idea, a genuine one. Because you are made of this universe, every atom in you was forged in a star. Every electron carries its quantum spin. Every molecule in your body is twisted in the direction the cosmos preferred. before this planet existed. And you are lying here, in the dark, aware of all of it, wondering about it, feeling it. Perhaps that is not separate from the spin. Maybe that is too large a thing to claim. I'm not sure science can fully answer it. Consciousness is still one of those places where the equations run out, but the smaller version of it is real enough. Matter, organized into something like you, has somehow begun asking where the spinning came from. Are we, the universe, finally becoming aware of its own turning? There is a thought I want to offer you very gently, not as a conclusion, not as an answer, but as something to carry with you into sleep. You have been here all this time, listening, breathing, wundern, following the thread of spin from the first second of the universe, all the way down into the molecules of your own body. And I want to ask you something. What is it, exactly, that has been doing all that following? Not the sound of my voice, not the words. Something inside you. Something that was already there before you pressed play, before this night began, before you knew anything about dark matter or spinning planets or the handedness of your own DNA. Something that notices. That is the thing I want to think about now, very quietly, without urgency. Every thought you have is a pattern of electrical signals, charged particles moving through the fluid of your brain, aligning and releasing, building and dissolving, in sequences so rapid and so intricate that the most powerful computers ever built cannot fully replicate them. Those charged particles carry spin. Quantum spin, the deep, intrinsic property of every electron that determines how it bonds, how it interacts, how it participates in the chemistry of a living cell. Every thought you have ever had, every memory, every fear, every moment of wonder, every time you looked up at the night sky and felt something you couldn't name, was built, at its foundation, from particles that are spinning. And those particles inherited their spin from the atoms that made them, which inherited it from the stars that forged them, which inherited it from the cloud that collapsed, which inherited it from the asymmetry of the early universe, which inherited it from something. The first turn, the one we cannot trace further, the one that started all of this. Your awareness, this quiet, present, wondering thing you carry inside you, is part of that chain. I mean this in the most literal sense physics allows. The universe has been spinning for 14 billion years. For most of that time, it spun without anyone to notice. Hydrogen clouds collapsed into stars. No one saw it. Stars exploded and scattered their elements across the dark. No one was there. Planets formed and cooled and gathered oceans. And still, for billions of years, nothing looked up. And then something happened. That may be the most extraordinary thing in the 14 billion year history of everything. The universe arranged itself in such a way that part of it could look back at the rest. not just react to it, not just be shaped by it. Wonder about it. You are that arrangement. A temporary, improbable, breathtaking configuration of spinning particles that somehow became capable of asking where the spin came from. There is a word in physics, emergence, for when simple things, following simple rules, combine into something that the rules alone could never have predicted. Water molecules have no wetness. Neurons have no thoughts. And yet, enough water molecules together, and there is an ocean. Enough neurons firing in their patterns, and there is a mind. What we call consciousness. This quiet sense of being present, of noticing, is something science still cannot fully explain. But whatever it is, it arises from electrochemical patterns in a brain made of spinning particles, not added from outside, just organized matter, somehow reaching a complexity where it begins to notice itself. Just spin, organized, layered, folded back upon itself, until it can feel itself turning. There is something scientists are searching for in some of the most careful measurements ever made of the ancient light of the universe. Faint, swirling patterns in its polarization, like the memory of waves on a beach long after the water has receded. Those patterns, if they exist, may be the echo of gravitational waves from the very first fraction of the universe's first second, ripples pressed into the fabric of space by whatever violent, extraordinary event set everything in motion. We haven't confirmed this yet. Instruments are being built and refined to look for it. The signal, if it's there at all, is hiding just below the noise floor of everything we can currently measure. If it is found, if those swirls in the oldest light really do carry the fingerprint of the first spin, then the beginning of the universe would still be visible, still present, still here, embedded in the light passing through the walls of this room right now. In a very literal, measurable sense, if those patterns are real, the signature of the first, second, would still be present in the light around us. It is all around you. It is inside you. It is, in some deep and unresolved sense, what you are made of. And you are lying here, in this particular darkness, at this particular hour, aware of it. That is not nothing. That is, I think, one of the most remarkable things in the 14 billion year history of the universe. Let everything go slack now. Your arms, your legs, your head. Let the floor or the bed take all of it. Let all of it rest. Completely. Without holding on to anything. You are resting on a planet that has been turning for 4.5 billion years. It will keep turning tonight, without any help from you. The galaxy will keep turning. The electrons in your cells will keep spinning. The ancient light will keep passing through. All of it. Every rotation, every orbit, every quantum flip will continue, exactly as it has always continued. You don't need to hold any of it together tonight. You never did. The universe was spinning long before you arrived. It will spin long after. And right now, in this small, warm, temporary moment, you are part of it. Not a witness to the spinning. Not an observer standing outside it. Part of it. The same motion, the same chain, the same unbroken thread that stretches back to the first second of everything and forward into whatever comes next. So rest. Let your breathing slow to whatever pace it wants. Let your thoughts go soft, not forced into sleep, just allowed to drift, the way a leaf drifts on still water without needing to go anywhere in particular. The wandering you did tonight, following spin from the beginning of the universe to the spiral inside your own cells that was not separate from the universe thinking. Maybe that's too large a thing to say. I'm not sure any of us can really hold it, but the smaller version of it is still true. That you, made of this universe, spent tonight wondering about it. And that is enough. And now, the thinking can rest. The spinning continues without it. It always has. Sleep now. And maybe that is enough for tonight. Maybe that is a softer way to think about it tonight. Not that the universe remembers us the way a person remembers a name, but that nothing about us is outside its story. The atoms in your hands, the breath moving quietly through your chest, the planet turning beneath the room. All of it belongs to the same long motion. And for tonight, that may be enough. If this quiet journey has stayed with you tonight, if something in it settled something in you, a soft like or a gentle subscribe, keeps this little world alive. It tells me someone was listening, that the words found their way. If you feel like it, leave a note in the comments. Just tell me where you are tonight and what time it is where you're listening. I love knowing how far these quiet stories drift, from one dark room to another, across the spinning world. Until next time, may the universe turn softly around you